Okay, the purpose of this video is to show the functionality of one of our MOFIS systems. So we call the MOFIS battery power N400 system with a 1x(n) optical switch. And in particular, we want to show the performance of the system and the functionality using the LabVIEW-based interface software. So what do we have here? Basically, we will have our system. Basically, over here we see we have the MOFIS system. We have our 1x12 optical interconnects. We will have our fiber bright gradient array that we use for showing the calibration setup. And right now it's running under battery power. On the other side, we have our computer. And in the computer, right now we have the software that we'll be looking into operating. Let's see if I can enhance this a little bit. I'm going to be running a program in the software that will allow us to capture the software screen. But basically, right now, we've been running a software version. It's called FBG MOFIS version 87, which is the latest version of the software we have. So what I'm going to do right now is I'm going to start the software just to get things going. So right now I'm just going to come here and start the software code. As we see when the code starts, we have this screen. Right now in this particular code, we see this yellow. There are two IP addresses that we identify, the software identified. One of the IP addresses, the one in yellow right now, is the computer is connected with an Ethernet cable for Ethernet communication. So the software identifies that Ethernet IP port. And the second port that I identify is the wireless port, which is the 1081.23. That's the wireless communication port, or the IP address of the wireless communication port in the radio installed in the computer. So this is how the software starts on the display. The next thing that I'm going to do is I'm going to power our MOFIS unit. So I'm going to power the MOFIS unit. Make sure that we're here. So I just turn the power on the MOFIS unit, and when you see that immediately what happens is the address for the Wi-Fi for the MOFIS unit Wi-Fi radius identified. So it gave us this yellow status. The other thing that happened is also it gives us the identification that the unit has a fiber optic switch. So this blue button identified that this particular unit has a fiber optic switch. We sell MOFIS that are single fiber connection MOFIS. That one doesn't have an optical switch, but this unit has one, and it identifies it. The other part that identifies is the battery power on the battery of the system. Right now, it tells us that we have 89.8% of the battery power. The other part that identifies is this box. You can see that the blue color is there. That basically means that the switching controls of the optical switch are enabled, so it allows us to do that. Right now, it tells us that we're switching at a speed of 25 milliseconds per fiber channel. And the last part that it shows the activation of the scan channels. So for example, I can change or activate different channels if I need to. So basically what this operation shows is that it recognizes the Wi-Fi, it recognizes the battery power, it recognizes the optical switch, and it allows us to activate the optical switch. So right now, that functionality of the software is running. Next thing I'm going to do, I'm going to start the software, the system running. So when I turn that on, we see that we're beginning to display data for the 4 different channels. These are the 4 WDM channels in the system. And this is the raw data. And we can see that it is updated. On the bottom plot, we see the Fourier transform of the data. Right now we're seeing the Fourier transform. But typically what we like to see during this initialization process, I want to switch from the Fourier transform view, and I'm going to switch to the Gaussian view. And these are the Gaussian filters on this particular unit. So that shows that. It shows us the functionality. So the next step, and I forgot to have that, but the next step is I'm going to switch to the processing commands. In the processing commands, we see that we have the capability to do downsampling. We have the capability to do calibration. We have the capability to do referencing, and we have the capability to do signal linearization, where the signal linearization is primarily used to transform the wavelength signature of the fiber Bragg grating into a strain measurement using linearization algorithms. So basically, I'm just going to show that downsampling works. So this is right now raw data. We're acquiring raw data at the maximum sampling rate. Right now, the maximum sampling rate that we get is 19 kilohertz per channel. So this is what is called raw sample data. And we can see the noise of the data. So let's say I'm going to pick up channel 1. So I'm only displaying channel 1. This shows us the noise parameter of the data. And it basically shows us that we have a noise level of about, let me stop this for a minute, and you can see it clearly. So it goes from about 2.94, 0.294 to 0.298, and these are volts. So basically it shows that our noise level of the system without the gratings connection is about 4 millivolts. Okay? Anyway, but this shows the raw sample. The next thing that I'm going to do is I'm going to switch to downsample data, and we're going to see how the downsample data is displayed. So right now, again, we're collecting data at 19 kilohertz. I'm going to downsample first to 1 kilohertz. You see how the data got smooth. And I can further downsample, let's say, to 10 hertz. So now we're at 10 hertz, and you see how the data averaging operates. We see a very smooth data sampling condition. Okay? So now we're running at 10 hertz, which is okay. We see the 10 number there. This number here actually gives us the actual downsample average. So we're collecting data at 9.2 hertz. Okay? So that tells us the actual. The next thing that I'm going to do is set up the calibration parameters. And typically when we set up the calibration parameters, we will need the calibration quality control. So we have this document called the quality control measurement report. And in that quality control measurement report, it gives us some of the calibration parameters that we need to use. I don't have the report right now with me, but it looks like the previous calibration that was done in this device is for this particular unit. So I'm just going to verify some of the things. So in the first column of the calibration, I tell us that we should enter the wavelength of the fiber Bragg grating sensor. I do have a fiber Bragg grating sensor array, and I want to compare that this array matches the wavelength parameters there. So on the first channel, the wavelength that I have is 1517.241, and this kind of matches that number. The next one is 1544.039. This is 1544.404. The next one is 1566.838. It's very close. And this one is 1514.491. So I think these numbers are very close to the fiber Bragg grating numbers that I'm using. In terms, the next slot is the wavelength, the center wavelength of the WDM filter installed in the units. And I believe these wavelengths are correct. I don't have the measurement report with me right now, but I believe this was the last calibration we did, and the same parameters are there. The next parameter is the full width half maximum. and we see that the full weight and maximum parameters have been entered. So the next thing, once these parameters are entered, which are usually given within the measurement report of the system, in the measurement report of the system, we provide the center wavelength of the WDM filters. We provide the full width half maximum of the WDM filters. And the user has the information for the fiber Bragg gradient array that they purchased or the one that we provided. In the measurement report, there will be a column that it will tell the user the optimum wavelength of the fiber Bragg gradients to use. And the optimal wavelength will occur at the 3 dB point of the WDM filter. Okay? Okay, so we have that. So once we enter those parameters, which actually now those parameters are also stored in the initialization file. So for example, if I go look at the initialization file of this system, we have this file called FBG moffice.ini. If I click that file, we will see that those parameters, the calibration parameters, are in that file, okay? And they are stored. So when the unit, the user can save this file, and when the unit is stored, is restarted, those parameters are going to come on automatically into the calibration setup. And that's basically what happened when I turned out the software. We had already stored these parameters. So the next step that we're going to do, and we're going to calibrate the unit. And there are two calibration parameters that we do. One is called the measurement of the signal offset. It's called the voltage offset. And the second measurement is the measurement of the voltage maximum. The voltage offset we acquire when there is no gradients connected to the unit. That's one of the conditions. The second condition is we do it when the optical switch is in the park position. So basically on the park position, the switch